Good morning, my name is Stuart Lewis, I work for Scientific, and today we are going to be using the Vernier EKG sensor in order to look at muscle activity within my forearm. Now, muscle tissues maintain an electrical imbalance or potentials across the cell membranes by concentrating positive or negative charges on the opposite sides of those membranes. These potentials are in a form of stored energy. With activation, such as from a nerve impulse, the ions are allowed to cross the muscle cell membranes, generating electrical activity and resulting in muscle contraction. An electromyogram, or EMG, is a graphical recording of electrical activity within muscles. It is useful in the diagnosis of disorders affecting muscles and the nerves that supply them. Inherited and acquired disorders of muscles, such as muscular dystrophies, and disorders of the central nervous and peripheral nervous systems, such as Huntington's disease and diabetic neuropathy, result in abnormal EMG readings. EMG studies are also useful for investigating normal muscle function. In this experiment, I will analyze the electrical activity in the extensor muscles of my forearm. These muscles originate in the tendons of the proximal and dorsal forearm in the region of the lateral epicondyle and attach distally to tendons which control the extension of hands and fingers. It is important that if you are going to attempt this experiment and you suffer from tennis elbow or other disorders of the arm or hand, please inform your instructor of any possible health problems that may be exacerbated if we participate in this exercise. Okay, so let's get a start. As you can see, here I have my Vernier EKG sensor. I have my contact pads, I have a weight, and I will be collecting the data using graphical analysis here on my iPad. The first data run will take the data as a nice baseline. I'll just keep my arm nice and still in this posture. The second data run, I'll just be flexing my hand up every 5 seconds. The third data run, I'll be doing the same, except I'll be using this weight. So I'll hold it there and flex upwards. And then in our final data run, we'll rotate that around the other way, hold on to it and flex upwards. From those, we'll be able to take the data and analyze it. It will be posted in a link attached to this video down below. You can also receive more information from Scientific's website, www.scientific.com.au. Okay, so to start with, I need to attach my contact pads to my arm. The first contact pad I'm going to place about 5 centimeters along this muscle. The second one will be 5 to 10 centimeters beyond that. The third contact pad will be on my arm. This will be the ground. I'll attach the green lead to the first one, the red lead to the second, and the black lead, which is my ground, to the third. Now that I have them all attached, I've turned on my EKG. I'll connect it to graphical analysis. Now for this, I'm going to change the data run from 3 seconds to 25 seconds so I can get good results. So we're ready to go. My arm is nice and relaxed and in a good position. I'll rotate slightly to make it easier for me. And here we go. Okay, we're now ready for the second data run. Now remember, this one is where I'm going to be flexing my hand upwards And I'll do that every 5 seconds. So I'll rest for 5, flex for 5, rest for 5, flex for 5. So rest for 5, and flex, and rest, and flex, and rest. We're now ready for the third data run. Remember, this one is now with a weight. So again, like the last one, I'll rest, flex, rest, flex every 5 seconds. Okay, now our final data run will be where I rest and flex the other way. So here we go. Okay, now that we've collected all our data, let's analyze it. The main analysis I'm going to be looking at is comparing the high and low voltage values. I want to see the change of voltage in my muscle potential as we go through this. On the baseline, it's a rather smooth, rather relaxed, so we don't have much change. But you can see the dramatic change when I start to flex my wrist. And now, if I look at it holding the hand weight, where I've had to make the muscle work a bit harder, you can see that there's an even greater increase of voltage. So one of the interesting things in the fourth data run is how little this muscle was activated. So when I had this turned over, and I was pulling here, this muscle, the one we were measuring, is not actually being activated overly much. So if you do have a problem with this muscle, say you have tennis elbow or a strain, injury, where you need to relax your muscle, you can then pick things up in this position to help relax that muscle. Now this has been a fun experiment. I do quite enjoy these. If you do have any suggestions for other experiments that you'd like to see, please leave them in the comments below. Information for this and other experiments can be found on Scientific's website. Thank you for listening. Stay safe.